My company is Equinox Analytics, and today's theme is makers. So I will introduce myself as a maker of maps. I'm a cartographer. Another way of putting that is I teach computers how to look for specific things in pictures. And we apply that to map making. And that's a little easier with an example. So picture yourself working for, say, the Minnesota Department of Natural Resources. You've all heard of the land of 10,000 lakes. Well, let's just say you're interested in knowing where those 10,000, or actually closer to hundreds of thousands of lakes are, because you want to manage habitat for wildlife. The way you would make a new map of all the lakes and wetlands in Minnesota is you would go out and you would find a contractor and they would fly aerial photography of the whole state. And you could get really nice, beautiful digital imagery of the state. This is an image from Minnesota, from a project that we're working on. But what you really want is not pixels. What you want is a map of the lakes. And so what you need to do is you need to have a person look at each picture and identify what's a lake and separate that out from things that look similar, like parking lots or rooftops. And this is a very labor-intensive process. Essentially, the state of Minnesota is going to spend about $4 million to take their aerial photography and translate it into a map of all the wetlands in the state. The way you get at this right now is through people power. You would hire some interns, or these are my competitors. We would see their student labor. It's offshore outsourcing, or in California they actually use prison labor to do aerial photography interpretation. And that's because it's so labor intensive and so expensive to do these things that you really need to find this labor shortcut. So where I come into things is about 10 years ago, I worked for a company that was an early adopter of a technology that was developed in originally the medical image analysis industry. So this same technology is used to analyze MRIs and CT scans and look for cell cultures, but they ported it over to geospatial data analysis. So basically what that means is we take software that was written to look at cell cultures under a microscope and we use it to look at satellite images in aerial photography. And what we do is write programs that identify boundaries. And so if you had to go through and identify where all the wetlands were in Minnesota, you might have to go through and draw that boundary of that wetland and draw that boundary of that wetland and ignore all these other boundaries of parking lots and roads and everything else. And so if you can write a program that does most of that work, you can eliminate a lot of this very expensive labor that goes into map making. That's what my company does. That's what I do. So I am a professional services company. I do consulting and contracting work. You would send me a hard drive with a few terabytes of imagery and airborne laser scanning data and digital elevation models. And my job is to take all of that data and synthesize it into a program that will spit out, these are the wetlands, and this is everything else that you're not interested in. So I take terabytes of data and deliver megabytes of information. That's what I do. And how does this pay? Why is this business, right? Because all that labor to draw all these boundaries is very, very expensive. So in the past, to draw this wetland in Minnesota, someone would have to start drawing this boundary. And by the time they got the boundary drawn and then the feature labeled, it took about 71 seconds to do that one wetland. You can imagine how many millions of wetlands there are in Minnesota. If we teach a computer how to find that boundary instead, all they do is click on it, select it, label it, and move on. So it takes about 6 seconds. So you can see where this time difference, as it scales out to the millions of wetlands there are in Minnesota, translates into money saved. So I'm a subcontractor to companies that do large mapping projects. I come in and say, hey, I can take a portion of the project fee, and I will write a computer program that will do 85% of the work. And you're still going to have some people go through and edit it and QC it. But what we want to do is make what they do more efficient and faster. So this is the product. I work as a subcontractor on this particular project to Ducks Unlimited. Ducks Unlimited is a nonprofit conservation organization that does mapping. They get a big contract from the state of Minnesota. I get a littler contract from them. I take their data, write my program, hand them some results, and their air photo interpreters finish it and produce this. This goes to the state of Minnesota. They sign off on it and write us a big check. So that's how the economic model works. But let's talk about something different. You know, that's wetland mapping. That's conservation. Conservation is a great thing to work on, but it doesn't pay all that well. So there are other applications. So this is urban tree canopy mapping. This is another thing I do where, say you're the city of Columbia, you might want to know where all of your street trees are because you need to plan for maintenance, trimming, stuff like that. And so you might take aerial photography of the whole city of Columbia, and then you would have the same problem. You would need to have some intern draw a boundary around each tree. And that intern is going to jump off a bridge after about 3 weeks of this stuff. I know because I used to do that, and that's why I got into writing programs to do this. So I have 6 seconds left. I'll just jump to my last thank you slide, and we'll transition into questions. But this is just a little bit about my business.
Thank you.
Oh, I didn't get the big klaxon.
You can close out. You can close out. Yeah. Just
All right. Well, in that case, I'll open up to questions. Just want to say thank you, and this is what my business is about, and I'm happy to talk to anybody about it afterwards. Thanks.
20 minutes.